Yeah, so today, I'm presenting the progress that we've made for the game Walkthroughs and Web Archiving project. Right. Yeah, so this project focuses, basically one of the goals is um, uh, to try to make web archiving entertaining like a spectator sport. And we've been exploring how to integrate gaming with web archiving and how we can gamify the web archiving process. So this figure here shows some of the different types of sessions for gaming, web archiving, and sports. And the first row shows sessions where only one user participates in the session. So for sports, this would be like practicing playing a sport like basketball. For video games, this would be like playing a single player game like Pac-Man. And then for web archiving, this would be like using a browser extension like Create to archive the current web page you're viewing. Then the second row shows sessions where there's multiple invited users. So for sports, this would be like playing a pickup game. For video games, this would be like playing an online multiplayer game like Halo. And then for web archiving, this would be like using a tool like BrowserStrix Cloud, where multiple users can work together when creating an archive. Then the third row shows sessions where anyone can participate by watching the stream. So for sports, this would be like watching a basketball game on ESPN Plus. For video games, this would be like watching a video game live stream by Twitch Plays Pokemon. And then for web archiving, this is like watching someone stream the archiving and replay sessions. So for this proof of concept, we've created gaming and web archiving live streams. The web archiving live streams are competitions between the crawlers, where we apply the game concept of a speed run to the web archiving process by having the competition be between two crawlers. And the first crawler to finish archiving the set of seat URIs would get a higher score. Then for the gaming live streams, they are influenced by the web archiving and replay performance results that was measured during the web archiving live stream. And watching the gameplay is another way to see how well the crawlers performed. Okay, so now we'll go over the process that we currently use for the web archiving live streams and the gaming live streams. Before starting the web archiving live stream, we need a configuration file and a file with a list of seat URIs. Then at the beginning of the web archiving live stream, Selenium is used to automate the web browsers that will display the context information needed for the live stream. Like the crawler's name, the current URL being archived, and the crawler's progress. So after the browsers are set up, we then give the crawlers the set of seat URIs, and then they begin archiving the web pages. And during this step, this is where the viewers can watch the web archiving process in action. Right. Then after the crawlers are finished archiving the web pages, we replay the web pages and show them beside the live web page so that the viewers can see how well the crawlers archive the web pages. Right. Since the viewers can see the archiving and replay sessions, this adds more transparency to the web archiving process. All right. Then at the end of the match, we show a summary of the web archiving and replay performance results that were measured during the live stream, and also compute the score for the crawlers. Right, and then these web archiving and replay performance results are then stored inside a performance results file. And these performance results are also used when creating the gaming configuration file. The game configuration file includes the settings for the game, which also impact the stats for the in-game players. So if a crawler performs well during the web archiving live stream, then their in-game player will have better traits, perks, and items. But if the crawler does not perform well and has bad performance, then their in-game characters will have worse character traits. Okay, so at the beginning of the gaming live stream, we use an app automation tool. to automate the interactions with the video game. Yeah, for like selecting the settings and customizing characters. So for browser games, we use Selenium, and then for locally installed games, we used Appium. Right, and so after the settings are selected, the match is started, and then the viewers can watch the match between the computer players. Okay, so we have supported 2 video games so far, which are Gunman 2 More Mayhem and NFL Challenge. Gunman 2 More Mayhem is a Flash game that's played in the web browser, and we use Selenium to automate the interactions with this game. When trying to automate the selections made inside the game, we had to use the game's HTML canvas, and then we use Selenium to like simulate mouse clicks to select certain positions on the canvas, so that we could select the buttons needed to select the game mode and also to customize the characters. And yeah, so for this first demo, we basically used the speedrun time to determine like which weapon to use. So like the crawler that was the fastest would get the fastest weapon, and the crawler that was the slowest would get the slowest weapon. And then also the crawler that won the match based off like their speed would get the perk, which makes it easier to complete basically to win the match. All right, and then for NFL Challenge, this is an NFL simulator that is like an older retro game that was played on MS-DOS originally. So we used the DOSBox emulator, and this is a locally installed application. So we use Appium to automate the interactions like when starting the game. Okay, so since NFL Challenge, like in order to run the game, you have to execute commands from the command line. We basically use Appium to send key presses to DOSBox for the commands that were needed to run the game. And to like before we would start the game, we would have to create files that the game could read associated with the teams. So there would be like roster files that have like all the players for a team and all the attributes for the players. And we modified those files so that we could basically use the web archiving performance to change the players' stats. And yeah, so for the first game, or for the first demo, I mean, we used the speedrun time to determine the speed of the players. And yeah, and also in this first demo, it was just one match between 2 crawlers. For a more recent demo that we recorded for NFL Challenge, we went through an entire season of like 18 games. And yeah, so for the season, we had 4 teams, which were the 4 crawlers that we used, which was Squidwork, Browsertrix Crawler, Rosler, and Scripter. And yeah, so at the end of the season, Squidwork like had the most wins in this case, because during the associated web archiving live stream where we got the performance results from, Squidwork had the most like archive resources, and we used that metric to determine like the attributes for the players, since most of the attributes were associated with like a specific position, like for example kicking, like for the kickers, and then passing for quarterbacks, and blocking for like offensive linemen, and yeah. All right, and then I guess another thing to mention for this demo was that we had to separate across 2 different live streams, because on YouTube, like you can have a live stream for however long you want, like for at least a long amount of time. But like once the live stream is over, if someone wanted to go back and watch the live stream, like only the first 12 hours would be, can be viewed. And then the remaining like hours after the 12 hours would be lost. So yeah, like for the season, it had 18 games. So, and basically each game was 1 hour. So it was like 18 hours in total to complete the season. So yeah, that's why we had 2 live streams for this demo. All right, so now we'll go over the different modes that we have implemented so far. So the first mode is archive mode, and this is where the viewers can watch the two crawlers archive web pages. And yeah, so during this mode, we also give both the crawlers the same set of seat URIs to archive. And yeah, currently when the crawlers like are archiving the seat URIs, yeah, basically it can only archive like those seat URIs and can't archive any other web pages, or at least like they shouldn't archive any other web pages. But yeah, in the future, we will allow the crawlers to like archive a website as well. Yeah, and so like if a crawler is archiving a web page and it takes a long time to like archive the entire web page, like for example, if it keeps dynamically loading content, then we have a timeout for like 5 minutes. That'll stop the crawler by default, and we'll add an option to change that timeout value as well. Okay. Now for the crawlers that we integrated, so far we've integrated Browsler, Browserstrix Crawler, wget, Scripter, and Squidwork. Right, so for replay mode, so this is where the viewers can watch, you know, like the replay of the archive web pages beside live web page. And currently we only allow recently archived web pages to be used during replay mode. But in the future, we will allow like work files from previous crawl to be used during replay mode. And yeah, so once we allow work files from previous crawl, you know, it requires some changes, you know, because currently we use the live web page as like to compare the archive web pages against. But like when we allow a work file from a previous crawl, it will require like us to like compare it to something else. So in this case, we would basically use an archive web page from a web archive that was archived during the same time. All right. Yeah, and then when going through the replay web page, like replaying the web page, like if it takes more than 5 minutes to go through the entire web page, we then have a timeout for like 5 minutes by default. Okay. All right. So the replay system that we have integrated so far is a replay web page. All right. And also for replay mode, we'll have an option for showing automatic annotations that are created by the web archiving live stream script. So in this image here, it's just showing like the first type of annotation that we've created, where basically it goes through and like for each embedded resource that's missing, that's able to identify, it'll just provide some extra information about the resource. So currently it just shows like the element type associated with the missing resource and the URIR associated with the resource as well. Okay, for results mode, this shows a summary of the web archiving and replay performance results, and also computes the score for the crawlers. Yeah, so currently the performance metrics that we use are the speed runtime, the number of archive resources for the different file types, and number of missing resources for different file types. So for determining the number of archive resources, we go through CDXJ file and count the number of resources with 200 status code. Then for the number of missing resources, we go through the CDXJ file and count the number of resources with 400 or 404 status code. And yeah, so these two types of metrics for the number of archive resources and the number of missing resources are something that we just temporarily included, and they will be replaced by the score that's calculated by the memento damage service. Okay, and then for results mode, we also like share the results with the viewers, or at least make it possible to do so. So the web page that's shown during results mode, it has like a QR code, and in the future we also add like a link as well. And if someone uses this QR code, it'll take them to the same web page. And when they're on that web page, they can download the performance results file that was created for that match. And also, there's a button up there, like on the web page, for like watching the round. And if they, click that button, it'll navigate them to basically the video timestamp URL that's like right at the beginning of when the match started for that live stream. Okay, and then we also like have web archiving tournaments. So we apply the concept of a tournament to the web archiving process by like having like allowing 4 crawlers to compete like in a tournament. And yeah, so the image on the right just shows like how it looks when the teams are progressing through the tournament bracket. And the scores that are computed here are just random scores, just like as an example. And yeah, so the web archiving tournaments are currently single elimination tournaments, like NFL playoffs or like MLS Cup, where if a team loses a match, they'll be out of the tournament and can no longer compete. And yeah, so in the future, we will have other types of tournaments like double elimination tournaments where a team could lose more than once, and a round robin tournament where teams have like an equal amount of times where they could play other teams. All right. So we have recently recorded a web archiving tournament demo where we have like the 4 crawlers, which Squidwork, Browser Tricks, and Scripter. And yeah, so this image here is just showing how it looks at the beginning of the match, where it showed the tournament bracket initially, then shows Selenium setting up the browsers, and then it ends with, showing the crawlers archiving the first web page. Okay, so for deliverables, we have created a dataset of seat URIs that we use for the web archiving live streams. And this dataset has 400 seat URIs in it so far. Okay, and then for the demos, like we recorded web archiving speedrun demo, which was the first demo we recorded, which just shows a match between 2 crawlers. And then we also recorded a recent demo where for the web archiving tournament, where it had 4 crawlers competing in the tournament. Right, and then for the gaming live streams, we showed we had a live stream where we had integrated the Gunman into More Mayhem with the web archiving live stream. And then for NFL Challenge, we had 2 types. We had 2 demos. One showing a match between 2 teams, and then another going through an entire season. Right, and then yeah, so another deliverable is that we will share the web archiving and game live stream scripts based on GitHub. Okay, yeah, so for future work for the web archiving live streams, we will apply more game concepts to the web archiving live streams, like having single player mode, tag team matches, and arcade mode. So for a single player mode, that basically will allow the streamer or the viewers to select like which crawler to use and the replay system to use for their team. And then their team will basically just see how many levels they can get through. Yeah, so for each level, basically it'll just be like one team archiving a set of seat URIs and then seeing like if they get a high enough score to complete the level. And then like the higher the level is, the more difficult it should be to archive the web pages. Right, and then for tag team matches, for this we'll have multiple crawlers on the same team. And they'll work together to archive a set of seat URIs. And they will like face another team of crawlers. We have multiple crawlers. Yeah, so for this, like we could have like a certain number of web pages that a crawler would need to archive before it switches to the other crawler, and they could just like alternate like that. Or another example would be like if a crawler is preferred for a certain type of web page or website, we can switch to that crawler in those specific cases. Right. Okay, so for arcade mode, this is similar to an arcade mode in like a fighting video game like Street Fighter, where like someone would select like one character, and then they'll try to basically defeat all the other characters in the game. And we could try to apply this to the web recording live stream by like allowing the streamer viewer to select like the replay system and the crawler they want to use for their team, and then they'll try to complete a lineup where it'll be a lineup of opponents to face and see if they can defeat all those opponents. All right, for the next future work, we're going to identify more motivators that can be used for the web recording live streams. So we'll try to, like for a live stream motivators I've seen, like one example would be like having interactive live stream where for example, like Twitch Plays Pokemon or YouTube Game On event, where the viewers had a choice and could impact what happens during the live stream. And this made their live streams more engaging with viewers and entertaining, because they could like influence what happens for the live stream. And yeah, so currently the web kind of live streams are all like predetermined, like everything's already pre-selected, like for the crawler, which crawlers to use, the replay system to use, and whether to have a web kind of speed run or a tournament. But yeah, so like having an option where we could allow viewers to make some selections during the live stream could make it more entertaining to watch. All right. And then I've also been learning about some other motivators for like playing video games and using gamification systems to see what could apply to the web recording live stream. Yeah, so for this, we've already included some motivators like having a web recording speed run and a web recording tournament, which is associated with the challenge motivation. But there's other types of motivators that we could include as well. Like one could be like for status, where we can see like if the team that someone selected will be able to make it to like a score leaderboard, like we'll have behind a score on the leaderboard. And another example would be like having rewards. So like having rewards, like for example, in single player mode, so that if the team completes a certain number of levels, it'll make it easier, or basically like give them a perk or ability that'll make it easier to complete future levels. All right. And for the next future work, we're going to integrate like the more archiving tools and web archives with the web archiving live stream. Right. And then for evaluation, we're going to check to see if applying game concepts to the web archive process, like is that enough to make the live streams entertaining? Right. And then we also will try to determine like the benefits for adding transparency to the web archiving process, through the streaming and the archiving and replay sessions. Right. Then for the gaming live streams, future work, we will support more games for different game platforms and game genres. The games that we supported so far are mostly like competitive multiplayer games, but there's other types of games that we could add support for as well. One example would be like a level editing game. And for a level editing game, we could like if a crawler has bad performance, we could add more obstacles or enemies on the level, and then see if their in-game character will be able to complete the level. Great. So in summary, we're developing a proof of concept that involves the gamification of the web archiving process and the integration of video games with web archiving. We have made the web archive process more transparent to third parties by live streaming the archiving and replay sessions. And we created automated web archiving and gaming live streams where the web archiving performance determined the capabilities of the characters inside the Gunman 2 More Mayhem and NFL Challenge video games. Okay, thank you for your time.